This video goes over lesson 1 in unit 6, and we're looking at page 4. You can get the notes for page 3 in the top of page 4 on the website, but this is just to go over the examples in there. Okay, so basically there's 2 rules when you're simplifying square roots. One rule is you can't have, your radicand can't have a number that it's divisible by that's a perfect square other than 1. And so I'm going to go ahead and put a list of our perfect squares at the top here. So we have 1 squared is 1. Everything is divisible by 1, so we don't use that. 2 squared is 4. 3 squared is 9. 4 squared, 5 squared, 6 squared, 7 squared, 8 squared, 9 squared, 10 squared, 11, and we're out of room, so we'll just leave it there. Okay, so we can't have any of those numbers, can't be divisible by, our radicand can't be divisible by them, and you can't have a radical in your denominator. So like on example 2a, 45 is divisible by 9, so I can't, this isn't simplified. So I'm going to rewrite this as the product of the square root of 9 times the square root of 5. I always put my perfect square first because square root of 9 can be reduced. It's 3. So it gets to come out of the square root, whereas that 5 has to stay in. So same thing with 72. 72 is divisible by 36. Just started to write the wrong number there. So 36 times 2, and you want the biggest perfect square that goes into 72. So for instance, like 9 is also a factor of 72, but 9 isn't the biggest factor. So we want the biggest one. So 36, and the square root of 36 is 6, and 2 is stuck in. 42 is not divisible by any perfect square, and so it cannot be reduced. We just leave it as the square root of 42. And 400 is divisible by 100, so 100 times 4, square root of 100 is 10, and that square root of 4. And then I realize, after doing that, I think, oh, well, square root of 4 is also a perfect square. So it's 2, square root of 4 is 2, so 10 times 2 is 20. If you end up canceling out all your square roots like that, that means that this is actually a perfect square itself. So if you just take the square root of 400, you're going to get 20. The only thing that's different, if you have a number out front, you're still looking for the perfect square that goes into 48. So 16 times 3. Square root of 16 is 4, so I'm actually going to do 3 times 4. So 12 root 3. So here's another example. 7. 243 is divisible by 81. It's 81 times 3. Square root of 81 is 9. 7 times 9 is 63, so 63 root 3. You can get the rest of those examples if you look at the notes on the packet. Okay, so let's look at example 4. So we've already talked about how to simplify them. If you were multiplying them, you can multiply the things that are on the outside, so the coefficients, and you can multiply the things that are on the inside, the radicands. So since these are both on the inside, we can multiply them, and then we want to simplify it. Square root of 9 times square root of 2. Square root of 9 is 3. That root 2 gets stuck in. Same thing on B. This has like a coefficient of 1 in front of it. 2 times 1 is 2. And then inside we do 12 times 2, which is 24. 24 is divisible by 4, so 4 times 6. Square root of 4 is 2, times 2 is 4. Same thing on C. 100 times negative 2 is negative 200. 5 times 6 is 30. 30 is not divisible by any perfect square, so that's as far as I can take it. So we're going to do the same thing on E. We have 3 times 9 times 4, which is 108, and then 6 times 2 times 10, which is 120. We want the perfect square that goes into 120, which is 4. Square root of 4 is 2, times 108 is 216. And that's pretty much it.